Review. The first objective that we're reviewing is how to simplify radicals. Now, radicals, if you're not unsure what radicals means, it's like a square root. Except a radical could have a square root. Remember, if there's a square root, there's like a little 2 here. Or else there could be really any number there at all. That's what a radical is. So first, before we get into that, we're going to review how to find and do a factor tree. So factor tree is looking at prime factorizations. What are all the prime numbers that multiply to get this? When you do your factor tree, you break it up into see what two numbers multiply to get 98. Now, because it is even, the easiest number that people typically start with, they're not sure what multiplies to get 98, is 2. So I can say 2 times 49 multiplies to get 98. Well, 2 is prime. So I can keep on breaking up 49. So 49 would be 7 times 7. Now 7 times 7 is 49. So when we do this, you can either leave your prime factorization like this, or anything that does not have branches, so 49 has branches, I can rewrite for my prime factorization. So 98 is equal to 2 times 7 squared. 2 times 7 squared because there's 2 7s right here. Right now, I want you to pause the video, and it'd be very beneficial if you try to do the prime factorization of 112 by yourself right now. So pause the video, try to do the same thing that I just did with 112. Now, I started off with 8 times 14. 8 times 14 equals 112. You could have started off with 2 times whatever that is. Your prime factorization should still be the same. I'm looking at the numbers that do not have branches because those are prime numbers. So I have 1, 2, 3, 4 2's. So this would be equal to 2 to the 4th times 1, 7. You can always check your work for this. When you're looking at your prime factorization, if I, in my calculator, if I do 2 raised to the 4th power, so this button right here is raised to the 4th power, and if I move that over, times 7, that should be equal to 112, and it is. It's kind of hard for you to see, though. So 112. So now we're going to actually get into simplifying radicals. So these are the steps. First, we want to do our factor tree. When we do this, I'm going to show you both how to rewrite it or just working off the tree. You find pairs without branches and you circle the pairs. All circled numbers, one number gets brought out of the root and multiplied together. All the other numbers that are not circled stay within. So now I'm going to do the first one, and then you're going to do the second one. So if I do my factor tree here first, 250, I'm going to do 25 times 10. And then 25 is 5 times 5, 10 is 5 times 2. Now, I'm going to show you this two ways. So I can work off just the factor tree. So I'm not going to rewrite it. I'm going to do or circle two numbers with pairs. So here are a pair of 5s. These don't have a pairs, even though I have 2 pairs here. Once I circle them, they're not in the group anymore. So these have to stay inside. So I'm going to box those in. Anything that's circled, one of those numbers get brought up. So 1 5 gets brought out of the root because there's 1 5 here. This 5 and this 2, those get multiplied and stay inside of the root. So this would be 5 square root 10. Now, if I wanted to do this with my prime factorization like this, times 2, I could also do this like looking for pairs of 2 here. So if I have a pair of 2's here, that means 2 5's make 25. So this would be like the square root of 25 times the square root of 10. Now the square root of 25 is 5. So this gives you a perfect square of 5. And I'm left with my square root of 10. I want you to pause the video and I want you to try to do it this way. I want you to try to do this way because this way is a little bit more complex. Pause the video and try to solve this format. Now here's my prime factorization. So again, only the numbers that are prime, that do not have branches. I'm looking for groups of 2. So here's a group of 2. I'm going to circle those 2. Here's a group of 2. So even though they're not on the same branch, they all stemmed from the 432. Here's a group of 2. This does not have any partners. I'm going to box that in right there. Anything that's circled comes outside the root. Only one of the pairs come out. So 1 2 comes out here. 1 2 comes out here. And 1 3 comes out here. This 3 has to stay inside the root. Notice how I put multiplication in between all of these. So now I multiply all these numbers that come outside the root 2 times 2 is 4, times 3 is 12. So this becomes 12 square root 3. Again, you can check your work for these. When I'm doing this, I can have, really can't see that. I can do the square root. So the square root is right here with my calculator. So second square root of 432. And I can combine or compare that to my square root here. So if I did 12 and then square root of 3, those two numbers are the exact same. So I know that I simplified my root correctly. So now if I look at problem 2, what happens if there's a number out in front? So first, if I do my prime factorization, 9 and 2, 3 and 3, I look for my pair. So here's a pair of 3s. So 1 3 comes out. So this 3 is already on the outside. This 3 comes outside of the root, and I'm left with this 2 on the inside. This 3 that comes out gets multiplied by any number that's already out there. So this would give me 9 square root 2. I want you to try to do B by yourself. So my prime factorization, I have a 2, 3 times 3 times 3 times 3. So there's a group of 3's here and a pair of 3's here. So I have the 5 that's already out there, 1 3 from this group, 1 3 from this group, and a square root 2 that had no partner. So now this becomes 15 times 3, which would give me 45 square root 2. Bing, bada, boom. That's all I have for you tonight. Have a great, grand, wonderful day.